aggregators package, we have a couple of classes. These are the aggregators that we're going to be using. And in the aggregator app class, when you download the code, this is what you're going to see. You're going to see all this code commented out. So if I uncomment out this code, right, we're of course going to have exceptions, okay, because this aggregator processor class needs to be implemented so that it can work with generics. So for now, I'm going to leave this code commented out, and we're going to uncomment it after I'm done reviewing some of the classes here in aggregators. Okay, that was part of the assignment. So hopefully you took a good look at how these classes work. So let's start with this aggregator.java. This is an abstract class, which means it's probably a parent of some other classes. So let's take a look at this class. Notice that it has a list of numbers. So any class that is a child of aggregator will have access to numbers. And it has a constructor. It has actually two constructors here, one without passing in a value, and the other does have a list that you can pass into it. Not important. We're not going to really be using these exactly. So let's go down here. We have an add method where we can add a particular number to this list of numbers. Okay, that's what this add method does. And down here is the key to how this aggregator stuff works. We have an abstract method called calculate, meaning that any class that is a child of aggregator, any class that extends aggregator, better implement calculate as well as get values. Okay, so let's take a look at one of the children of aggregator. We have min aggregator, mean aggregator, and max aggregator. Okay, this aggregator processor is your responsibility to complete. Take a look at this class. I don't have anything in here, so you're going to be filling out this class, but let's finish reviewing the min, max, and mean aggregator. So let's take a look at the max aggregator. This extends the aggregator parent abstract class, and notice that I've implemented the calculate method. And all this does is figures out the max number in the given list of numbers, all right? Then that list is this numbers variable, right? This is the numbers variable that was defined in the aggregator class, the parent. That's this guy right here, right? So since max aggregator extends aggregator, it has access to the numbers list. And we're iterating over that list, and we're trying to figure out what the largest value is, and that's what we return. Okay, that's what calculate method returns. And get values just, returns that list of numbers. The other classes are exactly, for the most part, the same. For example, min aggregator has a calculate method, and it works almost the same. It returns the minimum value from the list of numbers, okay? And get values does the same exact thing as what was being done in max aggregator. And now let's take a look at mean. In here we have the calculate method, and this does something a little bit different. It adds all the values that are in numbers, and then it just divides it by the number of values that were in there, and that's how you calculate the average, right? So if it has 1, 2, 3, 4, 5 numbers, it's going to add 1 through 5 and then divide it by 5, and that's going to give you 2.5. That's what this method does, and get values does the same exact thing as the other classes. All right, so that's a brief overview of that. Hopefully those classes made sense to you. So now let's uncomment out this code, and notice that it's giving exceptions. Hover your mouse on this, and it's saying the type aggregator processor is not generic, and we're using it in a generic fashion here. So like I said, you're not allowed to change this line here, okay? You can change the min or max aggregator that goes into this generic, but I want you to use generics. So let's take a look at this aggregator processor class, and let's start by defining the generic terms. So the first thing is going to be T extends aggregator. All right, so this class is now capable of working with aggregators. This T extends aggregator means any child of aggregator or aggregator can be utilized in this class. So when I define a variable of type T, and we'll call it ag, basically this variable is going to represent an aggregator. Let me name it entirely. I'll just say aggregator. And then we're also going to have another variable. We'll call it file. And now let's define a constructor for this. So we can right click and go to source and generate constructor using fields. Let's hit OK. And there goes our constructor. Now we're almost done with this class. The meat of your assignment was to implement this run run aggregator method, okay? This line is now compiling because we've implemented the generic functionality of it being able to accept aggregators. Now we need to implement the run aggregator method in this aggregator processor class. So let's get started on that. We'll do public. It returns a double, and it's called run aggregator, and it accepts an argument of type int, and we'll just call it column ID X because that's going to be representing the column that we want to aggregate over. So part of this assignment had to do with utilizing already written code, right? And we're sort of doing this here, but another piece to this was this stock file reader class, right? I didn't want you to rewrite the code for reading a file. That's already coded up in this stock file reader class called read file data. This method has already been coded up, so you can use this method in this aggregator processor. So let's define an instance of stock file reader, and we'll call it file reader, new stock file reader, and it accepts an argument of type string, and that is going to be the file name. So we have a variable up here called file, so we'll just use that down here, okay? And this file is going to be populated through the constructor as we're doing right here. Table.csv is passed in to this aggregator processor's constructor. So let's import stock file reader. Let's do the Control-Shift-O, and that brings in that. The next thing is we need to read the file data, and the file reader has this method called read file data, which you've already implemented. So we could just do file reader dot read file data, okay? And this is going to return. Let's take a look at that method again. This returns a list of strings, okay? So this represents each line, okay? This is basically returning each and every single line of the file. So that returns each one of these lines. This entire line is returned. Each line contains comma separated values, okay? So this list of strings basically represents the entire line. So we're going to use this read file data method to get the list of strings. So we're going to do list of string, and we'll call it values, or let's call it lines, because that's essentially what that is. And let's do a Control-Shift-O to bring in the import from the util package. And this is not going to compile because over your mouse it's saying unhandled exception, type IO exception. So we're just going to do add throws declaration, okay? Because this method is doing file processing, right? It's reading data from the file system. So if the file is not available or something happens during the read, we can run into an exception. So we need to handle that when we're invoking this method. So that's why I'm just going to throw that out to the console. Now we can iterate over this list of lines, right? So we'll do string, we'll call it line, and it's called lines. That's the container that contains each one of those lines. And then we could do line.split because each one of those lines has it's a string containing commas and values, right? So we need to split on the comma and return that in a string array, and we'll just call it numbers. All right. Now these numbers are, of course, they're not really numbers, they're strings. So let's convert each one of those strings to an actual number. So we could do number value is equal to double.parse, and we pass in the string. So it's going to be numbers at the index position call ID X. Okay, so this is the particular column that we are referencing. So each line is placed into this array of numbers, and if it's the first column, we want the first line, first number. If it's the second column, we want the second number, and so on. And remember, arrays are zero based, right? They start from 0 onward. So what we need to do, if I want to be able to represent the first column with the number 1, I want to make sure that I do call IDX up here minus minus. Okay, so before it enters here, even if they pass a 1, this is going to be changed to a 0, and it's going to get the right column. If they pass in a 0, that's not allowed. So we want the user to be able to use this from 1 onwards. We can put a check there if we need to, but I don't think that's important for now. So after this, we could do aggregator dot add, and we pass in the value dot double value. Okay, so this is just a method that exists on the number class, which converts it into a double value. There are other methods in here, such as int value, but we know we're working with double, so we can just do double value. All right, and it doesn't even have to be a number. We can just convert this to a double data type. Okay, and we won't need to do double value. So outside of this for loop, let's define a variable called number. We'll say that this is coming from the aggregator dot calculate. All right, so whatever aggregator that this class is instantiated with, whether it's a min, max, whatever, it's going to calculate. It's going to invoke that aggregator's calculate method, and then whatever that number equals, it's going to return. And there you go. That method is compiling, and I think that's it. Okay, so let's hit run. I'm going to right click and go to run as Java application, and notice that it's giving us 144.2899 for the first column, the max value. Okay, if I change this to a min aggregator, let's change it to all the different positions. Control Shift O to bring in the min aggregator. Now let's hit play and notice that it gives us 90. So it's behaving as expected. You can actually go to the Excel sheet and double check your values. So hopefully this was an intriguing assignment for you. It may have taken you a long time. It may have taken you not a very long time. It doesn't matter, as long as you're practicing and you're working hard at solving these kinds of problems. That's what's going to make you a better programmer. So let's wrap it up here. Thanks for watching. I'll see you soon.